All right, chapter 3, section 1, we're going to be solving quadratic equations. So in the past, we were solving just basic linear equations just with an x. When it's just an x, that would be linear. But here, quadratics are x squared. So we're most likely going to have two answers when it's x squared. So there's different methods we can solve quadratics by. A quadratic, again, is in the form of this. This is standard form, where it's a times x squared plus b times x plus c is equal to 0, where a, b, and c are real numbers, and a does not equal 0. So we can solve quadratic equations by graphing. So we would just take our quadratic function. We want to find the x-intercept. So to find the x-intercept, we would need to factor. And then we would just plot our points. So x-intercepts are where we cross the x-axis. We can solve quadratics by using square roots. So we would write the equation in this form, where we get the square root all by itself. So we would isolate. We would get the squared term all by itself. We isolate the squared term. And then we'd solve by taking the square root to get rid of that squared term. And then we can also solve by factoring. So we would put it in standard form and then factor it normally. So we want to solve by graphing. So looking at A, when solving by graphing, it's solving with factoring also, because we have to factor it in order to find the zeros. So for this one, I want to see what are two factors of -6 that add to -1. So that would be -3 and 2. So when I write my factors, I write it as x minus 3 and x plus 2. But now this is an equation. It's equal to 0, so it's a little bit different than what we were used to. Because before we would just factor it, we didn't solve. Now we're actually solving. So when it's equal to 0, I either need this to be equal to 0 or this to be equal to 0. So I'm going to set them both equal to 0. X minus 3 is equal to 0, and x plus 2 is equal to 0. Now I have two mini equations here, so I'm just going to solve for x. So I add 3 to both sides. So x is equal to positive 3. And then the other one, I subtract 2 on both sides. So x is equal to -2. So notice how from the original equation here, my signs change in my answer. So now I'm going to plot those 2 points. I have a point at 3 and a point at -2. Now, quadratic equations are parabolas. They're either going to open up or open down. If our x squared term is positive, it opens up. If the x squared is negative, it's going to open down. So here our graph opens down. It opens up, because x squared is positive. There's no negative in front of it, so it's going to open up. So this would be our graph. So all we need to do is solve, find our two answers for x, and then we would just draw our parabola through it. So the most important part is coming up with the two answers here. X is equal to 3, and x is equal to -2. For B, we're going to do the same thing. In order to solve, we have to have it be equal to 0 first. So this is first. It has to be equal to 0. So here it's not equal to 0. So I need to move that 4x to the other side. So I'm just going to do the opposite and subtract 4x on both sides. So it'll cancel out on the right. Now I'm left with nothing on the right. So that would be 0. On the left, I'm going to put it in standard form. So I have -2x squared minus 4x minus 2 is equal to 0. To factor, we always want to start and see if we have a GCF. So here I could take out a -2. So then once I divide everything by -2, I'm left with x squared plus 2x plus 1 is equal to 0. Now I want to see if I have two factors of 1 that add to 2, which that would be 1 and 1. So when I take out that -2, we ignore it because there's no x with it. I could just divide my whole equation here by -2 and by -2, so it cancels. And 0 divided by -2 is just 0. So I'm solving x squared plus 2x plus 1 now. This is my new quadratic function, my quadratic equation here. So two factors of 1 that adds 2 would be 1 and 1. So here I have x plus 1 and x plus 1. When I find the solutions here, when I'm solving, I set it equal to 0. So I just set each parentheses equal to 0. X plus 1 is equal to 0, and x plus 1 is equal to 0. I'm going to subtract 1 on both sides, so x is equal to -1, and x is equal to -1. So these are my two answers. The most important part here is solve. So we are solving. Graphing, not quite important yet. If we were to graph this, I have a point at -1, so it crosses the x-axis at -1. And because I'm graphing this, where my x is positive, my x squared, this term, is positive, my graph is going to open up. So it'll look something like this. So again, we're not really focusing on the graph right now. The important part is coming up with our two solutions for x. So again, for these two, we're just going to solve. We're not going to graph them. So we're just going to solve by factoring. So what are two factors of 12 that add to -8? That would be -6 and -2. So in my parentheses, I have x minus 6 and x minus 2, and that's equal to 0. So again, we're not done yet because we factored, but now we have to solve. So I'm just going to set each little equation equal to 0. So x minus 6 is equal to 0, and x minus 2 is equal to 0. Then I add 6 to both sides, so x is equal to 6. And I would add 2 to both sides, so x is equal to 2. So these are my two solutions to my quadratic equation here. If I were to graph it, I would have a point at 2, so I cross the x-axis at 2 and at 6. And then I would just draw my parabola through it, so something like that. But again, we're just focusing on solving. We don't have to graph yet. Number 2 is a little bit more tricky because I don't have a GCF here, and I start with a leading coefficient that's not 1. So to factor this, we have to multiply our first times the last. So 4 times 9 would be 36. Two factors of 36 that add to 12 would be -6 and -6. So here I have x minus 6 and x minus 6 is equal to 0. And the last step is we just set each of these equal to 0 as little equations. So x minus 6 is equal to 0 and x minus 6 is equal to 0. I would add 6 to both sides, so x is equal to positive 6. Same thing here, add 6 to both sides, so x is equal to positive 6 again. Those are my two solutions. So for all of these quadratics, you will end up with two solutions. Sometimes they're the same, sometimes they'll be different. So next, we're going to be solving the quadratic equations algebraically. So to do this, we always want to get the x squared all by itself. So get the x squared and then equal to everything else in our equation. So this has to be alone. We got to isolate the x squared. Once we isolate the x squared, then we square root. So this is step 1. Step 2 is to take the square root. So if I had x squared, if I take the square root, it cancels out with the squared. But if I take the square root of one side of my equation, I have to take the square root of the other side too, which we'll do some examples and it'll make a little bit more sense. So step 1 is get the x squared term all by itself. Then we take the square root of both sides. So looking at example 2, we have to solve each equation using square roots. So for A, I would need to get my x squared term all by itself. So I'm going to add 31 to both sides. So 4x squared is equal to, this would be 80. Step 2 is divide both sides by 4. So x squared is equal to 20. And then once my x squared is all by itself, then I take the square root of both sides. Now, anytime we take the square root of both sides, this is super, 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 super important. Anytime we take the square root of both sides, we have to put a plus or minus in our answer. So this is positive or negative square root 20. And then lastly, we always have to make sure our square root is simplified. So this is what we did back in our first test. We got to simplify 20. So 2 factors of 20 would be 4 and 5. 2 factors of 4 are 2 and 2. So any pair comes outside. So this would be plus or minus 2. Whatever is not a pair stays on the inside. So x is equal to plus or minus 2 square root 5. So anytime you take the square root of something, you have to put that plus or minus. Anytime you take the square root of both sides when solving. All right, so next let's look at B. So again, we need to isolate the x squared. Got to get that all by itself and move everything else to the other side. So we're going to subtract 9 on both sides. So 3x squared is equal to negative 9. Then I'm going to divide both sides by 3. So x squared is equal to negative 3. And then I have to take the square root of both sides to cancel out with that squared. So now I'm just left with x. And that's equal to, whenever we take the square root of both sides, you need a plus or minus. So plus or minus square root negative 3. Now I can't simplify the square root of 3, so I can just leave it like this. All right, we're going to skip C for now. We can come back to it when I come back, but we're going to skip it for now. So let's take a look at 4 on the next page. So we want to get our square root, our squared term all by itself. So I'm going to start by moving the 14 to the other side. So 2 over 3x squared is equal to 6. Next, I need to move that 2 over 3 to the other side. So I could divide both sides by 2 over 3, but a little bit easier step would be to multiply both sides by 3. So whatever our denominator is, because then that will cancel. So then I'm just left with 2x squared. So whatever is in our denominator, we can multiply that to get it to cancel out on both sides. And then 6 times 3 would be 18. Now I still have that 2 being multiplied to the x squared, so I'm going to divide both sides by 2. So x squared is equal to 9. And then lastly, we take the square root of both sides. Anytime we take the square root of both sides, we need a plus or minus in our answer. So x is equal to plus or minus, and the square root of 9 is 3. So this would be our answer. All right, now let's look at 5. So I need to get that x squared all by itself, so I'm going to subtract 1 on both sides. So I have negative 2x squared is equal to negative 7. And I'm going to divide both sides by negative 2. A negative divided by a negative becomes a positive, so this is 7 over 2. And then once my x squared is all by itself, I take the square root of both sides. So x is equal to plus or minus square root 7 over 2. Next, let's look at 6. So I need to get the x all by itself. So I'm going to start by dividing both sides by 2. Move that to the other side. So it'll cancel out there. So I have x minus 4 squared is equal to negative 5 over 2. Now before I touch anything inside these parentheses, I have to get rid of the squared first. So to get rid of the squared, I need to square root both sides, because the square root will cancel out with the squared. So on the left side, I have x minus 4. On the right, we still need that plus or minus square root negative 5 over 2. And then the very last step, since we need it to be x equals, we have to get the x all by itself. So I'm going to add 4 to both sides. So x is equal to 4 plus or minus square root negative 5 over 2. And the 4 comes first because we always put the rational number first and put the square root second. So the whole number first. And the square root would just come after it. Yes, it would be wrong if you put it the other way around. Got to have that whole number first. Right. Next, we're going to solve our quadratic equations by factoring. So when the left side is factorable, you can solve the equations using the zero product property, which just says that once we get it to be factored, we just set each piece equal to 0 to find our solutions. So example 3, we're going to solve by factoring. Just like before, we have to have it equal to 0 if we're going to factor it. So I need to subtract 45 on both sides. So x squared minus 4x minus 45 is equal to 0. Now I need 2 factors of negative 45 that add to negative 4. So that would be negative 9 and 5. So in my parentheses, I have x minus 9 and x plus 5. And then the last step is to set each parentheses equal to 0 and make them their own equation. So I have x minus 9 is equal to 0 and x plus 5 is equal to 0. And I solve for x in each of them. So now these are 2 separate equations. We just solve for x. So add 9 to both sides. X is equal to 9. And then my second equation, I'm going to subtract 5 on both sides. So x is equal to negative 5. These are my 2 answers. So again, notice here how it was x minus 9 and positive 5. And then our answers became positive 9 and negative 5. So the signs always flip once you get to your answer part. All right, for example 4, we're doing the same thing. So always check and see if you have a GCF. When it says find the zeros though, just to go back to the directions here, finding the zeros is the same thing as solving. So these mean the same. If it says find the zeros, it means the same thing as solve. So to find the zeros of our function, we can set it equal to 0. Or we could make the f of x equal to 0. Same thing. We want to find what x is equal to. So always check and see if you have a GCF. Here we do not. All 3 of these numbers are not divisible by the same thing. So we start by multiplying the first times the last. So 2 times 12 is 24. Two factors of 24 that add to negative 11 would be negative 3 and negative 8. So in my parentheses, I have x minus 3 and x minus 8. Whenever we start with multiplying, we have to remember to go back in and divide. So that 2 is going to go in front of the x because we can't simplify there. In the second parentheses, I can simplify, so this would be x minus 4. So then from here, I just set each of my little equations equal to 0. So 2x minus 3 is equal to 0, and x minus 4 is equal to 0. Then we solve for x. The first one, we have 2 steps to do. I'm going to add 3 to both sides. So 2x is equal to 3. Then divide both sides by 2. So x is equal to 3/2. That's one answer. And then the second equation, I'm going to add 4 to both sides. So x is equal to 4. That's my other answer. So you'll end up with 2 answers for these questions. So there's my 2 answers. All right, next let's look at 7. So again, solving by factoring. What are 2 factors of 35 that add to 12? 7 and 5. So x plus 7, x plus 5 is equal to 0. Now to find what x is, I set each of these equations equal to 0. So x plus 7 is equal to 0. X plus 5 is equal to 0. To solve my first little equation, I subtract 7 on both sides, so x is equal to negative 7. Second little equation, I subtract 5 on both sides, so x is equal to negative 5. So there's my 2 answers. So again, notice here how it was a plus 7 and plus 5, and my answer turned into a negative 7 and negative 5. The signs always change. All right, next let's look at number 8. So if we're going to solve, it has to be equal to 0. So I'm going to move that 2 to the left side and put this in standard form. So I have 3x squared minus 5x minus 2 is equal to 0. Now here I don't have a GCF, so I have to start by multiplying the first times the last. That gives me negative 6. 2 factors of negative 6 that add to negative 5 would be negative 6 and positive 1, x minus 6, and x plus 1. But we cannot forget, since we started by multiplying, I have to remember to divide. Simplify if we can, so this becomes x minus 2. If we cannot simplify, we put it in front of that x, so this would be 3x plus 1. Now I just set each of my little equations equal to 0, so x minus 2 is equal to 0, and 3x plus 1 is equal to 0. The first one, I'm going to add 2 to both sides, so x is equal to 2. That's one answer. Second one, I first need to subtract 1 on both sides. So 3x is equal to negative 1. Then divide both sides by 3. So x is equal to negative 1/3. Those are my 2 answers. All right, last question we're going to do here is number 9. So again, we are finding the zeros, which is the same thing as solving. So I can set this equal to 0. We just need to solve. So here, I don't have a third term, so I can't factor this normally, but I do have a GCF. My greatest common factor between x squared and negative 8x squared would be x. So I can take out an x, so I'm dividing both of these by x, and I'm left with x minus 8. So x minus 8 is equal to 0. Once I factor it, I just set each of these equal to 0 as their own little equation. So x is equal to 0, and x minus 8 is equal to 0. So x minus 0 is, x is equal to 0 is already solved for us. We're done there. That's one answer. And then the second one, I just need to add 8 to both sides. So x is equal to 8. So there's my two solutions. Then we're going to skip 10 for now. We can come back to it on Thursday when we come back to school. But you guys just have to do up through 9. And if you finish the notes, you guys can start working on the homework.